Oh, by the way, before I forget, because some people email me, sorry about Tuesday, not COVID related. I've been having some stomach issues since like January, and I keep ending up in the emergency room. But I'm fine, not COVID related. Every time it's antibiotics, so like they're concerned I'm going to get immune to the antibiotics. It works every single time. I'm fine a day later, but I've done tests. Who knows? It's probably something age related. They tell me to eat more fiber. But anyways, to the Apple thing. So, I mean, I write software for both of them, and my software companies wrote software for both of them. So I don't care, whoever writes the check, right? At the end of the day. But I think there's validity to both sides. I mean, really, isn't Microsoft solving the harder problem? They're writing an operating system that runs on 1 million different computers, where Apple's writing an operating system that runs on just their computers. They control both sides of the coin. Yeah, I run a Mac, but I have one machine that I use for everything. So, I mean, this machine has 64 gigs of RAM in it and stuff like that. So I have all my virtualizations. I run Windows on this and stuff. So it's just one machine that I carry with me. It's pretty portable. I probably do prefer Mac because it's closer to Unix, and I prefer having like a terminal and stuff like that. But I mean, if you're really trying to give, props to somebody, Microsoft is solving the harder problem. I mean, it's really shocking how well Windows works when you consider it has to run on everybody's hardware, all sorts of different processors, all sorts of different graphics cards, things like that. Yeah, where it's, not really surprising that, like, even on the iPhone, it's not surprising that, iOS is probably better than Android from an end user experience. It just kind of works. But they're writing it for their own hardware, where Android has to run on 4 zillion different machines. So it's really impressive how well Android has come along. In the early days, Apple was clearly better than Android in almost every single measure. Today, it's you pick your poison. Frankly, for me, it comes down to a single feature. My wife still runs iOS because I write software for it, so we have development devices for both. But this is the Note 20 Ultra, the new Samsung, and I was considering going back to iPhone this time, but it really did come down to a single feature, and that is when you set up a hotspot on Android versus iOS. Anybody know the difference? The thing you can do on Android with hotspots that you can't do on iOS? For me, it's the killer app. On iOS, when you turn on your hotspot, your Wi-Fi goes off, right? You are sharing your data plan, your cellular data plan, with other folks. Android, you can share a Wi-Fi connection. So I go on a lot of cruises. So it's not uncommon. Internet's expensive on the cruises. So I will, and my wife and I always get the internet, but now I can sit at the wine bar and I can share my internet with other people who just want to check their email and stuff like that. You'd be shocked how many free glasses of wine I get. It's like tipping. But in all sincerity, like just the other day, we were at a place, and you know how they have, you'll be out and about, and there's like Spectrum Wi-Fi hotspots, but then there's like the Spectrum Ultra, like the better Wi-Fi that you need to be a Spectrum higher end customer in order to have access to. Well, I have access to that. So you might be in a place that has crappy Wi-Fi otherwise, but I can share Spectrum Ultra or whatever it's called with the people that are around me through my hotspot. So it's like little things like that, 90% of the time or even more, it's not that big of a deal, but because of the way I use the device, it's, I would say, handy. Where that has very little to do with the operating system as a whole, and just one way they handle one feature. That's helpful for me, but other people might not necessarily care about. Okay, so let's, all right, see, we've already accomplished a whole bunch of stuff. We talked about the advantages of Android. We talked about how the death of Flash. We talked about how Microsoft is often demonized for something that they really did a pretty good job with. It's like the first 7 minutes of class. Go ahead.
How is Professor Gonzalez doing?
Reverend Dr. Gonzalez?
Yes, Reverend Dr.
He's doing great. he's doing great. One of these days, maybe my wife will let him leave the house again. He still travels with us, but he goes in a Ziploc bag, you know, so he doesn't become a carrier of anything. Otherwise, he has to go through quarantine when he gets home. We were quarantining way before COVID in the Lippman household. All right, let's see here. So I put up the solution to the first programming assignment, right? All right, let's just go through, because what I had you do for the second one is expand upon that with Scanner, right? But let's talk about Scanner a little bit for doing input, output. So actually, let's just kind of throw it in here. I think I gave you a link to go read on Scanner, but let me kind of give you my Reader's Digest version of that. So Scanner class in Java. All right, so historically, and actually let me show you the old way of doing this in case any of you happen to go and look stuff up. You used to, if you wanted to read something in from the user, typically I've mentioned multiple times that Java is a string-based language, right? So if we can get things into string format, we have a lot of flexibility. I just made a guess that maybe the Slack message was because somebody was stuck in the waiting room, but they weren't. You have a lot of flexibility if you can get things read in as a string. Well, Scanner has not been around forever. So before that, what we used to do is we would create an input stream reader and a buffered reader that wraps around that. So let me kind of show you what that looks like. I'll just cut this for right now. So what we would do is we would create an input stream reader. We'll call this guy input, and I'll go ahead and hover over this, and we'll import java.io.inputStreamReader. And our input stream reader would be created out of a new input stream reader, out of a new input stream. Actually, was it in buffer? I think it's just an input stream. System.in. All right, so you would create an input stream called whatever. But, oh, I'm not sharing the screen. That was the. Why doesn't somebody speak up?
That's what I'm doing.
Now you're like 3 minutes late after the Slack message. I hate all of you. And I don't use that term lightly. All right, so everybody can see the screen now? All right. So we're going to create an input stream. I'm showing you the old way of doing this, and I'll show you how Scanner kind of fixed this-ish. Not the end of the world, but so we created an input stream. Now, the thing is, with an input stream, it allows you to read things in a single character at a time. But we really like strings. So then what we needed to do is we needed to go and get another tool from Home Depot for kind of making the, adding some functionality to the ability of reading things in one character at times. So we went and got something called a buffered reader. And we'll call this guy BR, and this is going to be a new buffered reader built out of input. So kind of wrapped around our input stream. And this guy also lives in java.io. Now you notice that both of these guys are underscored in red. So in Java, and it exists in Python too, we just didn't cover it, but we have these things called exceptions. Most modern programming languages have the ability to, let's call it crash gracefully. So rather than the program just dying, they allow you to, and in some cases, like in this case, they force you to deal with it. So they're saying, well, you know what? Under normal circumstances, something bad could happen here. So rather than your program crashing under those circumstances, we're going to force you to deal with it at this level. It might never come up. You could pass the buck if you will, if you want. I'll show you that in a second. But at the very least, when I hover over input stream, it says, oh, I can't instantiate an input stream. Is my stuff dated here? Guess it doesn't necessarily matter. I'm going off of memory here. Maybe it was an input stream reader. We give this 2 minutes and then I'll just explain it anyways, but I'll just say this is the way it used to work. I really thought it was a buffered reader. Oh, whatever. I'll look it up, but this is the old way of doing it. Is you used to have to create some kind of input stream wrapped around a buffered reader. The input stream lets you read in one character at a time. The buffered reader allowed you to digest it one string at a time. But what would happen is you could potentially, when you try to create one of these, perhaps this input stream, in this case, system.in is your standard input stream, which is the keyboard. Something could go wrong if you were reading from a different input stream, which could be something over the internet or something like that. Go ahead. Well, yeah, but that doesn't help me with the rest. Or did buffer reader fix that? No, whatever. I'm just going to keep going. All right. So in any case, you used to have to do something like that in 2 lines. But the idea is that as our programs became more and more network aware, the nature of our input streams would change. We weren't just reading in from the keyboard. We'll be reading in over a socket internet connection or even from a hardware device or something like that. So they came out with this thing called the scanner, which is built into java.util, which made the act of reading things in from the user more convenient. All right, so I'll go ahead and create my scanner here. So I'll say scanner input is equal to new scanner. And for the scanner, you have to tell it what stream are you reading in from. And I'm going to read in from system.in. All right, so it's going to want me to import java.util .scanners. Notice here there's a bunch of different scanners for different things that come with some Sun tools and stuff. One of them allows you to, if you're ever interested in writing your own kind of thing that allows you to process Java syntax at the same time as your program running, you can use the javac parser. This is the Java compiler parser, which Scanner works with. But the one we're using is the one that comes with a standard java.util library. All right, so we have that. And now what we'll do is we can just say system.out.print, enter something. And then we'll say string val is equal to input dot, what's it, next line? And then I'll just spit out val. So now what I was getting at here a second ago, and I'll kind of pretend to do it here in a minute, we used to have to create this buffered input stream and all this stuff, but then you would have to wrap it in something called a try catch, because something bad could happen in case the input stream you were trying to do use didn't exist. It exists with file IO. You try to read in from a file and the file doesn't exist, it would scream at you. Well, languages, modern languages that have exception handling built into them, they'll force you to handle the potential of those things or pass the buck. And I'll show, I mean, at some point when we actually have a real one of those pop up, I'll explain it to you. I'll give you an example. But the idea is you can either wrap all the stuff you're trying to do that might cause a problem inside what's called a try-catch block. Even though nothing in here can potentially throw an error. Or at least, actually it can give you a runtime error, but it won't force you to catch that if it's a runtime error. But in any case, I'm basically saying here, I'm gonna try to do all this stuff. And if something bad happens, I'm gonna catch the generic exception and be able to handle it gracefully. Even though I'm not doing anything inside the curly braces there, I'm handling it ungracefully. But I'm at least given the opportunity to interject if I'd like. All right. Now, since reading stuff in from the user, you might imagine is a fairly common task, you might decide that, hey, this is a little bit inconvenient for me to have to throw tries and catches all over the place just to read something in from the user. Hence the scanner, which builds those things internally, and you're able to just kind of read stuff in, deal with it, blah, blah, blah. And actually, I could probably force a an example here. All right, so I'll go ahead and run this. I'm reading something, I'm saying enter something, I'm reading it in, I'm just gonna print it out, but then I'm gonna print out that value. We have a method called parseInt that lives in the integer class that lets you kind of convert the value to an integer, but only if it's numberable, integerable. All right, so if I run this, enter something, if I say 124, that works. So I get 124 printed out as a string, then I'm converting it to an int, and now that's printing out as an int. But if I run this again and I type in LOL, I get this exception. Number format exception for input string LOL. So one thing I can do is I can say, well, this guy right here could cause a problem. So I'll go ahead and try to do this. I'll catch an exception. And instead of having the normal error that shows all this red stuff on the screen that we don't want to see, I'll just say woot instead. So there's my nice friendly error that's completely meaningless. But because I put in LOL, and then I tried to turn LOL into an integer, which doesn't make any sense, right? I caught the bad stuff, the exception, and dealt with it however I wanted by just spitting out the value woot. Now, in this particular case, this exception right here is what's called a runtime exception that integer.parseInt throws. So they don't actually require you to handle it. So normal exceptions, Java will scream at you if it says, hey, this particular function you're trying to call throws an exception, you are responsible for dealing with it or passing the buck. And we'll have an example at some point where I pass the buck, but you know, at least in this case, we see that an exception can happen if I'm using parseInt and I try to parse an integer out of something that can't be parsed out. I can then choose to deal with it in a more interesting way. Like maybe I say, please enter a number or something like that. Go ahead. Yeah, I could say something like you must enter a number, something like that. And then if I really want this to, I can probably wrap this in like a while true. Throw all this stuff inside of there. And then after I successfully parse it, I can break out. Otherwise, I'll just give them the error message and it'll spin back up. So enter something. I'll type in LOL. It says you must enter a number. I'll type in woot. You must enter a number. Finally, I'll type in a number and it breaks me out of it. Because notice that I tried to do all this stuff, but the exception happened right here. And because the exception happened right there, I didn't get to this line that broke me out of my loop. Instead, that had the exception. I caught the exception. I said you have to enter in a number. Then I let this while loop naturally spin back up and it had them enter in another number. Until they finally gave me something where this line here did not throw an exception, which I was then able to break, and I fell out of the while loop. Right, makes some sense? But we'll see plenty of examples of exception handling. I just kind of threw it out there as part of the history of why Scanner works the way it works. It used to be, I'm actually surprised that I input string reader and was it buffered input string? Whatever it was, I'll have to look it up. It was inconvenient to do IO historically. It was like 3 or 4 lines with a try catch to make it work, where now you just create a scanner and you're done. I'm not sure it necessarily changed the world or anything, but did force you to get acquainted with try catches earlier on. But Scanner lets us accomplish this stuff more easily now. So the second version of the homework was to read something in. And then what were we doing? Counting vowels. So I'll read in my thing. I'll have a int count. Start that off at 0. I have found 0 vowels. I'll create a string vowels. And this guy will be A-E-I-O-U, A-E-I-O-U. So upper and lowercase vowels. I know in looking at some of the code, a lot of you had the crazy asking a zillion question if statements. If it's equal to an A, or it's equal to an E, or it's equal to an I, or all those things. You can use we looked at some of those string methods last couple classes, and one of them was index of. It kind of allows you to maybe search within it. I kind of compared it to the find function that we had in Python. So what I can do is I can create a loop that goes through all of the characters in val. So for int I was equal to 0, I is less than val.length, I++. Then we'll ask the question, if the current character I'm looking at, which is val.char@I, that's a character, the current character in val. If when I see that guy and I search for it inside of vowels, if it gives me something that's not a -1, that means, if it gives me something that's not a -1, that means it found that character inside the string called vowels. -1 means I looked, I didn't find it. So anything other than that, 0, 1, 2, 3, that means this character is in the string vowels, which has all the vowels in it. Therefore, if it was something other than -1 that popped out of index of, I'll go ahead and say count ++. Otherwise, I'll just move on to the next character. In the end, system.out.println count. All right, now notice they did give us a little orange squiggly under input. Technically, when you open up a stream, you're supposed to then close the stream. So good programming would say at the end we put input.close, or we can even put it as soon as we're done reading in. Doesn't matter, but just if we opened a stream, we also close the stream. Not the end of the world, just more of good programming practice. So enter something. Why doesn't it kick me down into the executable box rather than up there by the code? I'll put an elephant and it shows me that there's 3 vowels in there. All right, make sense? All right, so that's a solution to the homework assignment for today. And I think actually what I can do is, yeah, technically this is still for homework 1, but I'll go ahead and just say updated for homework 2. I'll commit this to master and then push. So now my GitHub repository has the latest version of that code in it. All right, questions about basic Java programs, writing some loops, doing some variables, IO stuff?
I have a question about this homework assignment.
Sure.
Is there, so like in Python, we had like the dot lower and dot upper thing. Is there something similar to that? So you wouldn't have to have the string vowels have the upper and the lowercase, but you could.
Yeah, so you can switch this to like that, and then you can say something like maybe vowels or val is equal to val dot 2 lowercase. So now you're guaranteed that val has all 2 lowercase, has all lowercase letters in it.
Okay. Okay, thank you.
Okay, so let's look at some other loops. So I take you through some other tools here. Up to this point, we've looked at the normal structural loops inside of Python. The counting loop, the for loop, it's kind of like something in a range. But if you remember in Python, we could also do something like for, if we just dump this here, I can say string s is equal to elephant. And in Python, I could have done something like for c in s, do something, right? And then I can say something like print c, and that would print out e, then it would print out l, then e, so on and so forth. If I want to do the same thing inside of Java, we have something called a for each loop. So I can say for each char c in s, I think. Strings are iterable. It's just for char c in s. Does it tell me this is not iterate? Yeah, I can't do it over a string. So let's look at arrays real quick. So I can't do that over strings because strings are not something called iterables, but I can do something like here's a quick and dirty way of turning a string into a character array. So the string class, just like it has the index of and the char at method, and we saw 2 lowercase today, also has the ability of quickly converting a string into a character array, which is like a list in Python. So now I have a character array called AR, and I'm going to say for each character C in AR, I'm going to go ahead and say system.out.println C. And this will give me elephant 1 character per line. Because this guy right here, this is for this value, specifically this type of value in this collection. Each time through C is the next character in there. It's an E, then it's an L, then it's an E. But I had to turn it into a character array first because strings themselves are not something called iterables. Yeah.
when you're doing the like for char, is it always per seat?
Well, it could be other things, because what if I have a integer array called AR2, and this is a 1, 2, 3, 4, 5. So this is a collection of ints. Now I can say for int LOL in AR2. Yeah. Println LOL. So I'm going through a different collection. This happens to be a collection of integers. Make sense? So now if I want to go through each element in that, I need to create a variable here. You can name it whatever you want. Up here I named it C. Down here I'm naming it LOL. But the difference is up here this guy was a char, because this guy here is a collection of chars. Here, this guy is an int because AR2 is a collection of ints. So now I can spin through that and get every element in that list. Now, keep in mind, you don't have to do it this way for either of those. I can say for int I is equal to 0, I is less than AR.length, I plus plus, system.out.println, AR at bucket I. I can certainly do that. Similarly, down here, I can go AR2.length, AR2 at bucket I. So these two loops have the identical output. What is the difference between them? What do I have access to in the second loop that I do not have access to in the first loop? Out of what I have highlighted here. Yeah, I have that integer I. The second one, I know which bucket in my array I'm currently looking at. I'm looking at bucket I, bucket 0, bucket 1, bucket 2, bucket 3. In the first one, I have each character that exists in that char array, but I don't necessarily know where it is in there. Now, I'm not necessarily needing this value of I outside of just indexing it. So in this particular example, I would say, well, this is good enough because I only needed the chars that were in there. I wasn't using the character somewhere or the position somewhere. But let's say that I wanted to keep track of maybe the last position in a string where that a vowel was found in. The position of the last vowel, something along those lines. All right, so let's do that, but let's do that in the context of writing a function in Java. So keeping our movement forward with Java. So I'll go ahead and I'm going to write a function down here. And this guy is going to be static because everything's static for right now. He's going to return an int, and we're going to call this guy last index of vowel. And he's going to take a string as a parameter. All right, so he's going to go through this string and return the position of the last vowel in that string, or a -1 if it's not in there. So I'll put a little comment. We'll say returns the position of the last vowel in the string, or a -1 if not found. All right, go ahead and take a couple of minutes and try to write this on your own, and then we will do the solution here. So write a function called last index of val that takes a string, and this guy should return an integer, which represents the last bucket in string S where a vowel was found, or a -1 if we found no vowels. All right, so let's take a look. So again, when we're thinking about functions, we want to keep ourselves writing things generically. So inside this function, the string we're operating on is the string named S. How many characters are in S? So if all you see is this right here, how many characters are inside the string called S?
The length of S.
Yeah, S dot length number of characters. You know, don't get tempted into looking up here and saying, oh, there's 8, right? All we know is that this function is going to receive a string as a parameter. And that string is going to have some number of characters in it. That number of characters is S dot length number of characters. I want to go through all those characters, and I want to return the position of the last character in that string that is a vowel. So I need to do something pretty similar to what I had before with my vowel string. So I'll have a string vowels is equal to A-E-I-O-U, A-E-I-O-U. And then I'm going to go through every character in my string. Well, I'm going to keep track of my pause as well. Actually, I don't even need the pause. I'm going to go through every character. So for int, I'm going to call this int pause is equal to 0. Pause is less than or equal to, actually we'll just say less than S dot length, because the last legal character in the string is its length minus 1. And we'll say pause plus plus. Now each time through, we want to say, is this a vowel? How do we ask if something's a vowel? We could say, if the vowel string, when I look up the index of s dot char at I, or s dot char at pause, when I look up the current character in the vowel string, if it gives me something other than a -1, that means I'm looking at a vowel, correct? So I'm going to keep track of last vowel pause. I'm going to start that off at -1, because that's what I'll return if I find no vowels. So if I found a vowel in here, I'm going to set last vowel pause equal to the current position that I found that vowel. I can't return that value yet because I want to return the last position in the string where I found a vowel. So I got to keep looking, but as I start the string from the beginning towards the end, whenever I find a vowel, I update the last vowel pause to be the current pause I'm looking at. Once this loop is done, I'll go ahead and return the last vowel pause, which might still be -1, what I started it at. If I checked every character in the string and I never found one vowel, that means I will not get into that if statement even one time. And therefore, I will not have returned last vowel pause. I will not have changed last vowel pause, so it'll still be its original value of -1. Make sense? So this guy will give me the last index of a vowel. So in this guy here, this is bucket 0, that's the first index. Bucket 2, 5. So I should get a 5 out of the string elephant, right? So I'll say system.out.println driver.last index of, I'll pass it S. I'm not going to explain the details behind it yet, but when this guy is static, he belongs to the current class. So you can call him using the name of the class. You don't have to. You can leave the driver part off. But notice here, by me putting driver dot, it went ahead and spelled out the name of the function for me, so I didn't have to worry about misspelling it. That'll become clearer as we get farther into this, but in any case, I'm going to call this method that I wrote, I'll pass it S, and I expect to get a 5 out of that guy, the position of the last vowel in that string. And if I go ahead and throw a bunch more things in there, I get a later number. We'll just assume it's correct. All right, question about that? So we've practiced throwing something into a function. We've worked with the generic length of this guy and put our vowel stuff inside there. So getting used to Java syntax for things that we've done before.
I have a question.
Sure.
Would you be able to do it in a way where it just like started at the last letter in the string and then walked backwards and just returned to the position of the first vowel it found?
Yeah, you would have to probably operate off of the length. So if I write this a second time, let's call this 2. What I'll do is I'll start off at s dot length -1. Keep going as long as pause is greater than or equal to 0. Walk backwards. If I'm looking at a vowel, I'll return s dot length minus s dot length minus pause would give me the offset from so if the length is 8, I would have to keep track of, no, I think this will work. Actually, I don't even need to do anything crazy. I could just say pause. I don't have to do any funky stuff with the math because it will be the actual index. So yeah, I won't need last vowel pause. If I'm out here, I just return -1. So that'll do it. Start at the end of the string. This is the actual position in the string. Walk towards the front of the string, including the first element. Step backwards by 1. If I'm looking at a vowel, that means I'm looking at the last vowel because I'm walking the string backwards. So I'll just return the current position. But if I go through the entire string and I never returned in here, that means I didn't run into any vowels. So I'll just return a -1. So that's the version you're looking for.
Thank you.
All right, other questions about this? All right, so we looked at our for each loop. I think we've looked at a while loop in here, but if we haven't, I'm actually going to show you something interesting that just popped up. So what happens what would the output of that program be? First of all, what's a byte? It's a byte data type. We talked about our primitive types built into the language. We reminded ourselves that Java is based on C, so these older languages came from a time where memory used to be really expensive. Now it's not so expensive, so you're probably not going to see bytes real often, but we're going to show it here just for the sake of time. So what is a byte?
Byte's 8 bits.
Okay, it's 8 bits.
So-
Well, tell me more about the byte data type. It is 8 bits, but specifically, what kind of values does the byte data type hold?
Number less than 16.
Number less than 16. Okay, where are you coming up with that from?
I thought that I remembered that. Sounds like I was wrong though.
I made it up. So, so shorts are 2 to the 16th power. They're 16-bit values. Bytes are 8-bit values. Now, bytes, shorts, ints, longs, these are all signed whole numbers, meaning they can hold positive and negative values. So a byte is a 8-bit signed number. So it can hold negative 128 to positive 127. That's the range of values. Those are the 256 unique values. That is 2 to the 8th power. 256 unique values that can be held inside of a byte. All right. So the largest value that a byte can hold is 127. The smallest value a byte can hold is negative 128. So what's the output of this program going to be?
Print numbers 1 to 127, all on a separate line.
Okay, well, probably 0, because the first value is 0, right?
Oh yeah, sorry.
Okay, so it'll print out a 0, then it adds 1 to that, so it'll print out a 1, then a 2, then a 3, then a 4, all the way up to 127. Then when I add a 1 to 127, what do we expect will happen? Well, we got some options, right? I mean, to an extent, I'm asking you to guess, to predict. I mean, program could crash, right? 127 plus 1 is 128. Can a byte hold the number 128? No. So it might just die, right? Might crash. Any other suggestions on what might happen? Go ahead. Negative 128. That is what it does. And you'll see this in the 325 class next semester, the computer organization and architecture class. We talk about how negative numbers are actually stored. They're stored in a format called 2's complement, which I won't get into here because it's not something that's part of this class. But effectively, if I take the binary number 127, which is 11111, 8 ones, and I add 1 to that, I'm going to end up with the number 1 with a bunch of zeros after it, and that is a 2's complement encoded value for negative 128. So it does wrap around, but it doesn't wrap around artificially. The math makes it wrap around. If I add 1 to 127, I get the encoded version of negative 128. I add 1 to that, I get the encoded version of negative 127, negative 126, negative 125, so on and so forth. All right, so 2's complement is compatible in that it allows us to store 256 unique values, of which we are choosing negative 128 to positive 127. It also mathematically works for doing addition and subtraction. It gets us to the right place without us having to have like special cases. So before I answer that, just so you can see it real quick, you'll see this guy just keeps wrapping. And I promise if you change the byte to a short, it would do the same thing. It would just wrap at 32,767. It'll go to negative 32,768. You did it for ints, it'll do negative 2.1 billion. If you do floats or doubles rather, we would just be waiting for a while. But it's like 16 quintillion. Go ahead.
So why would we use like the byte?
Realistically, if we're talking about the modern programmer, historically, the answer to that would be if you never had to hold a value outside of negative 128 to positive 127, being a good steward of your computer's memory, you should use a byte. That's your smallest footprint in memory that you could use. Modern programming would say, look, I got tons of memory, I'm not going to be inconvenienced. So really today, when would you use a byte? You'd probably use it if you were working with like streaming video or something like that, where things are coming in 1 byte at a time. Yeah. Well, we don't have that data type. The primitive data types built into Java are byte, short, int, long. Yeah, those are the whole signed values. You could certainly create a object type that would allow you to deal with things in megabytes or something like that, but you'd have to write it yourself. Yeah, yeah. These are just the things that are primitively built into the language. Bytes, what we got, which is 8 bits. Short is 16 bits. Int is 32 bits. Long is 64 bits. All right. So that's more of a trivia type thing, but you see how you actually can get an infinite loop out of addition, and it just keeps wrapping out around on itself. We don't run out of numbers. We just cycle back. And you'll see if I change this to a short, we'll get the exact same thing, except the largest value be 32,767. All right, but if we were working with a kind of a traditional while loop, we might say int I is equal to 0 while I is less than 10, system dot out dot println. Now I'm going to write this here, even though I would never encourage you to write it this way, but tell me what the output of this program is going to be. Notice I put the plus plus after the I. So what will my output of this program be? Very important skill set is being able to read code and resolve what it's going to do. I mean, especially things this size. Go ahead. You think just 0? Well, what is this? What is a while loop? What does a while loop do? What do loops do? Well, what is the plus plus after versus the plus plus before mean? Let's break this into pieces. When we talked about the plus plus operator, we talked about the difference between it coming before the number and coming after the number, right? So when it comes after the number, what does that mean? That means we get the current value of the number and then it increments, right? Now, a while loop says we're going to repeat something a bunch of times. So I starts off at 0. Is 0 less than 10? Yep. So what am I going to print out? Well, I'm printing out I plus plus, but since the plus plus comes after, I'm going to get the current value of I. What's the current value of I right now? 0. So I'll print out a 0. Then I'm going to increment I. I is now 1. Spin back up. Is 1 less than 10? Yep. What's it going to print out? A 1. Then the 1 becomes a 2. 2 less than 10? 3 less than 10? 4 less than 10? 5 less than 10? So this is going to print out 0 to 9. But if I change the location of the plus plus to be before that, now it's going to print out 1 to 10. Because it's incrementing first and then boiling down to the value that's in there. That make sense? But if we just printed out I here and then incremented on the next line, it wouldn't matter whether we knew it was plus plus after or plus plus before, because this is going to give me the same output 0 through 9, whether I have the plus plus before or the plus plus after, because I'm doing the increment on its own line, rather than trying to be fancy and save a line of code. But you still should know the difference between plus plus before and plus plus after, because you need to be able to read other people's code. So I'm encouraging you not to confuse the issue by wrapping it yourself inside of something until you're supremely confident in how it works. But a skill set that you need, and if you remember back to last semester, we talked about being able to look at a line of code and resolve it to what its output is. You know, kind of, we talked about it in terms of like the Boolean expressions. Sometimes you can look at something that looks very complex, but ultimately it boils down to a single value of true or false. So when you look at just a couple of lines of code here, we want to be able to walk through them and say, okay, well, this guy is a variable. I is holding a value. What's a while loop? Well, it's a loop, so I'm going to probably do something repeatedly. Remember, this goes right back to our fundamentals of programming languages allow us to remember stuff, ask questions, and do repetition. So as long as the result of this question is true, I'm going to keep doing this stuff. So I'm going to print out the 0, then I'm going to print out the 1, then I'm going to print out the 2, all the way up to until I finally fail this, and that's when the 10, or an I is equal to 10, which is no longer less than 10. Make sense? What would the output of that code be? Just 0?
Wouldn't it print out like unlimited zeros?
Yeah. We're going to have 0 forever. Okay, so, you know, he mentioned we have a 0. You know, you just didn't want to keep saying zeros, get locked in. Okay. Second guess was this is going to do 0 10 times, but we actually never changed the value of I. So this says, is 0 less than 10? Yep, print out 0. Is 0 less than 10? Yep, print out 0. Is 0 less than 10? Yep, print out 0. Until you just get tired of it. And then we hit the little stop thing. So if you get into an infinite loop and your code's just doing that, you can hit this little red button here to get it to stop. That make sense? So again, get into the habit of looking at code and resolving it and decide, what do I think this will do? And that's as opposed to trial and error. One thing you want to move away from as a programmer, especially now where you know enough to be dangerous, is you don't want to get into the situation where you just keep changing things and trying it without really asking yourself, what do I expect this to do? It's okay for you to expect it to do one thing and then get a different result, and then ask yourself, well, why was it that? Why did I get the different result? Because then learning has taken place, right? But if you just try every permutation of something, you haven't really learned anything. You just, through brute force, got something to work. You've tried every single possible permutation of it, and it just finally kind of worked out. What time are we out? 12:50? Okay, thank you. All right, so there's our while loops. Do while loops, which we really didn't have. They do exist in Python, but we really didn't have a great example of them. So I'll go ahead and we'll say do system.out.println I plus plus. Actually, here we're going to keep tricking you here, force you to resolve this stuff while I is less than 10. So a do while loop is what's called a post check loop instead of a pre-check loop. So we will execute the body of this loop at least one time prior to asking our question. So I starts off at 0. We're going to go ahead and print out a what? What prints out on that line if I start off at 0? A 1. All right. Then we ask the question, is 1 less than 10? It is. That's a true statement, right? So we'll spin back up and we'll print out a what? 2. So on and so forth, all the way up to 10. So last time through we printed out a 10. Is 10 less than 10? It's not, so we fell past it. what would the output of that program be? All I changed was this one line. Started off at 100 instead of zero. What would my output be? Yep, 101. So I start off at 100, first time through, because with the plus pluses before it, we incremented first, now we're at 101, then we got the value, so it prints out 101. Then we get to this and we heavily fail, right? 101 is definitely not less than 10. So we fall out of it, but we got 101 out of this guy. As opposed to if I said I plus plus, then we have just gotten 100, right? Because we would have gotten the current value and then incremented. So there's our 100. Make sense? So do while loops, because they are post-check loops where the body exists at least, happens at least one time. We can't avoid that. They lend themselves to problems where we need to do something at least once. And the common problem for that is like authentication. If you need somebody to give you a username and password at least one time, they might have screwed it up. You might need to ask them again, but you still need them to give it to you once. That's where a do while loop might play a role. So you probably see them significantly less often. Probably for loops show up the most often just in common practice, followed by while loops. For each loops are also pretty common if you don't need to know the index. But ultimately, this comes down to the right tool for the job. But frankly, if you only used while loops your entire career, you could get away with it. Just knowing that this is how the loop works. But for loops are pretty common, so understand kind of the differences in the loops and which one makes the most sense for different situations. But generally speaking, any problem that can be solved with loops can be solved with any of the loops, as long as you added the appropriate if statements and stuff like that to block special cases. Okay, so let's talk about the next assignment and then talk about what goes into it. So for Tuesday, you're going to be writing a Java program that'll prompt the user, again, using our scanner, for a decimal number. And then it displays to the screen the binary equivalent as a string. So you have to do this using division, modulo, concatenation. There is some, the point is there's something built into Java that will allow you to do this conversion trivially. You're not allowed to use it. Okay, so you have to convert from between a decimal number and a binary number yourself using string concatenation and looping and things like that. String concatenation, as a reminder, if I have the string S and that's equal to hello, I have the string S2 and this is equal to world. And then I say string S3 is equal to S concatenated with a space, concatenated with S2, just like in Python. Then we can say system.out.println S3. And we get those things put together. Another interesting trick that came up in one of the programming assignments, somebody, I don't remember what was the context of it, but it was something along the lines of, oh, I wish I could have a char be a string. So the idea here is if I have s.charat2, for instance, what is s.charat2? That's bucket 0, bucket 1, bucket 2. That is the char L, correct? What if I have the char L and I want to turn that into the string L? So C as a string. How do I turn this character into a string? This goes back to this thing that Java is a string-based language. We can move between strings and other types very conveniently. Anybody know how I might make? This is a convenience of Java that does not exist in Python. Remember with concatenation in Python, both sides needed to be string types? Java, only one side has to be a string. So I can turn a number into a string conveniently as well. What string would I concatenate the contents of C onto to have a string that only contains the contents of C? This is the empty string. It is a string because we have double quotes, but it's a string with length 0. And I'm concatenating onto it the contents of my variable C. Notice this guy is, how do I know that's a variable as opposed to the character C? How do I know that's the variable C and not the character literal C? Character literal C would have single quotes around it. If I don't have single quotes or double quotes, Java's going to look at this and say, that's a variable or it's a syntax error. Okay, so if I put LOL or something like that in there, or if you wanted a single character, it'll say W. It's going to say, oh, well, I don't see a variable named W. And you haven't put double quotes or single quotes around it, so it's not a literal. It's not a string literal. It's not a char literal. You must be trying to tell me about a variable. I don't see a variable named W. But I have a variable named C, whose contents is L. This will produce for me the string L. And the string L has a length of 1. The string L can be converted to uppercase. Technically, you can convert chars to uppercase too, but we'll cover that a different day. All right, so a hint here would be, if you want to build up a string from nothing to something, you might operate off of the empty string as your base. And you did that last semester. But last semester, you had to make sure that both sides were string types. Where now, only one side needs to be a string type. All right, so for example, if we read in 123, and I give you a hint here that you can use integer.parseInt on the string 123, and we saw this earlier today, right? We saw the errors it could throw and stuff like that. But if I say integer.parseInt on 123, I will get the number, the decimal number 123. There is another version of integer.parseInt that will do most of this assignment for you. You're not allowed to do that one. Use that one. You can only use this one, the one that doesn't take the erratics you wanted to convert it to. So assuming you have the int 123 that you've read in from the user, you should display the binary equivalent of that, which means that you have to go back and learn and remember the conversion of going from binary to, or from decimal to binary. And that's the pattern where we divide by 2 over and over again and record the remainder and record the quotient. So you remember, just do integer division. 5 divided by 2 in Java is 2. 5 mod 2 in Java is 1. Because this is 2 remainder 1. So this is equivalent if we were dealing with Python here. This is 5//2. Remember the double slash dictated that I want to do integer division, not floating point division. Otherwise, 5 divided by 2 will give you a 2.5. Make sense? So you're going to need this mod operator to get the remainder. You're going to need single division, because integer division is the default, to get that. And you're going to want to build up a string to ultimately give you the binary version of it. Okay, questions about this homework assignment? All right, questions, comments, concerns, bribes? All right, this is due Tuesday. I will see everyone then. Any questions from online?